Have you ever wondered what makes your computer tick or how you can boost its performance with just a few upgrades? You're in the right place. Welcome back to our PC maintenance and hardware class. Today, we're diving into Module 3, where we'll explore the secrets of supporting processors and upgrading memory. If you find these tips and tricks useful, make sure to hit that like button, subscribe to our channel, and share this video with your friends. And don't forget to leave your comments and questions below. I'd love to hear from you. Let's get started and unlock the full potential of your PC. Ready to dive in? Let's go! By the end of this module, you'll be equipped with some powerful skills and knowledge. You'll understand the different types of processors and what makes each one unique. We'll cover how to choose the right processor for your needs, as well as the steps to install and upgrade it. We'll explore various types of memory and their roles in your computer system. You'll learn how to boost your system's performance by upgrading its memory. Stick around as we break these down and show you how to apply this knowledge to keep your PC running at its best. Alright, let's dive into processors, the brains of your computer. Think of the processor as the power behind your system's performance, and it's installed right onto the motherboard. When we talk about processors, Intel and AMD are the two big names you'll come across. Each has its own set of features and strengths, so getting familiar with them is key. Now, let's break down what really affects a processor's performance and how well it meshes with your motherboard. Processor speed. This is measured in gigahertz, GHz, and basically tells you how fast the processor can do its job. Higher GHz usually means better performance, but it's just one piece of the puzzle. Lithography. This is about how small the processor's transistors are, measured in nanometers, nm. Smaller transistors can lead to better performance and efficiency, so it's something to keep in mind. Socket and chipset compatibility. The processor needs to match the socket type and chipset on your motherboard. If they don't match, you'll have trouble getting everything to fit and work properly. Multiprocessing abilities. This includes several cool features. Multiprocessing. Using more than one processor to handle tasks. Multi-threading. Each core can handle multiple threads, making multitasking smoother. Multi-core processing. More cores mean the processor can handle more tasks at once. Dual processors. Some systems use two separate processors for even more power. We've covered the basics, so now let's look at some additional features that affect performance and compatibility. Memory cache. This is like the processor's quick access storage. It speeds up data retrieval by storing frequently used information right on the processor. More cache usually means better performance because the processor doesn't have to keep reaching out to the slower main memory. Memory features on the motherboard. The motherboard needs to support the type of memory the processor uses. If your motherboard can't handle the memory features that the processor supports, you might not get the full performance benefit. Support for virtualization. This allows a single processor to act as if it were multiple processors, running different operating systems or applications in virtual environments. If you're into running virtual machines or advanced computing tasks, this feature is essential. Overclocking. This is like giving your processor a bit of extra juice. It involves running the processor at a higher speed than it was originally designed for. While it can boost performance, it also comes with risks, like increased heat and potential system instability. Now, let's touch on processor architectures. Today's processors generally fall into two categories. Hybrid processors. These processors combine 32-bit and 64-bit capabilities. They're designed to handle both older and newer applications, making them versatile and widely compatible. 64-bit processors. These are specifically designed to handle 64-bit operations, which allows for more memory usage and potentially better performance with modern applications. Understanding these features and architectures will help you make informed choices about upgrading or selecting processors for your system. Now, let's take a deeper dive into Intel processors. Let's take a closer look at the different families of processors available for desktops and laptops today. Understanding these will help you choose the right one based on your needs and budget. Intel Core processors are divided into several categories. Core X series. These are the heavyweights, designed for high-end desktops that need top-tier performance, especially for tasks like gaming and content creation. They come with powerful graphics and are ideal if you're looking for serious power. Core i9 and Core i7. These are also high-performance options, but Core i9 is the absolute powerhouse, and Core i7 offers great performance for high-end desktops and laptops. They're perfect for demanding applications and multitasking. Core i5. This is a solid choice for mainstream desktops and laptops. It offers a good balance of performance and value, handling everyday tasks and some heavier applications without breaking the bank. Core i3. If you're looking for an entry-level processor, Core i3 fits the bill. It's great for basic computing tasks on desktops and laptops, like browsing the web and working with office applications. Pentium processors are designed for entry-level desktops and laptops. They're budget-friendly and suitable for basic computing needs. Atom processors are geared towards low-end desktops, notebooks, and laptops. They're designed for efficiency and long battery life, often found in budget-friendly or compact devices. Celeron processors are another option for low-end netbooks and laptops. They offer basic performance for everyday tasks and are typically found in very affordable devices. Each of these processor families is tailored to different needs and budgets, so knowing what each one offers will help you choose the right processor for your specific requirements. Let's keep going and see how these processors fit into the bigger picture. Now, let's talk about AMD processors, which are quite popular, especially in the gaming and hobbyist markets. They're often known for being more budget-friendly compared to their Intel counterparts while still offering strong performance. For desktops, AMD offers several families. Ryzen. These are AMD's mainstream processors, known for their solid performance and value. They're great for a wide range of tasks, from everyday computing to more demanding applications. Ryzen Threadripper. If you're looking for raw power, the Threadripper series is where it's at. These processors are designed for high-end desktops and are perfect for gaming enthusiasts and professionals who need top-notch performance. Athlon with graphics. These processors come with integrated graphics, making them a good option for budget desktops that still need decent graphical performance without a separate GPU. Ryzen Pro. Tailored for business environments, Ryzen Pro processors offer enhanced security and stability features, making them ideal for professional use. Athlon Pro. Similar to the Ryzen Pro, but more budget-friendly, Athlon Pro processors are suited for entry-level business desktops. For laptops, AMD has Ryzen, providing excellent performance and efficiency for a range of laptop models, from ultrabooks to gaming laptops. Athlon. These processors are designed for budget laptops, offering basic performance for everyday tasks. Chromebook. AMD's processors for Chromebooks are optimized for Chrome OS, providing a good balance of performance and battery life. For servers, AMD's EPYC processors are impressive, with some models featuring up to 64 cores. This makes them a great choice for high-performance computing tasks and data centers. AMD processors are a fantastic choice for many applications, offering strong performance and good value. Whether you're into gaming, need a solid workstation, or are setting up a server, there's likely an AMD processor that fits the bill. Now, let's dive into ARM processors. ARM stands for Advanced RISC Machine, and it's designed to simplify computing instructions. ARM processors are known for being low cost, low power, and generating minimal heat, making them perfect for mobile devices like smartphones and tablets. Several major companies use ARM technology. Samsung powers many of their mobile devices. Intel uses ARM in some product lines. NVIDIA includes ARM in various devices. Qualcomm, their Snapdragon chips are ARM-based. Apple uses ARM for their M1 and M2 chips in Macs. ARM's efficiency and versatility make it a key player in mobile and embedded systems. As a hardware technician, you might be called on to perform several key tasks involving processors. Here's a quick rundown of what you might be doing. Assemble a computer from parts. This involves putting together various components, including the processor, to build a functioning system from scratch. Exchange a faulty processor. If a processor goes bad, you'll need to replace it with a new one to get the system back up and running. Add a processor. In some cases, you might need to install an additional processor, especially in systems that support multiple processors. Upgrade an existing processor. Upgrading a processor to a newer or more powerful model can boost system performance and keep up with demanding applications. In each of these tasks, it's crucial to match the processor to the system to ensure compatibility. You'll also need to know how to properly install the processor onto the motherboard to get everything working smoothly. Understanding these tasks and the steps involved helps ensure that the system runs efficiently and meets the user's needs. Selecting the right processor is crucial for ensuring your system performs at its best. Here's what to keep in mind. Check motherboard compatibility. First and foremost, make sure the processor you choose is supported by your motherboard. Each motherboard is designed to work with specific processors, so compatibility is key. Opt for the highest performance. If your motherboard supports it, go for the highest performing processor it can handle. This will give you the best performance possible. Consider multitasking ability. Look at the processor's ability to handle multiple tasks simultaneously. A processor with strong multitasking capabilities will perform better in demanding applications. Balance performance and power. Ensure that the processor's performance and power consumption are well matched with the rest of your system. You don't want a high-performance processor if the rest of your components can't keep up. Read reviews and benchmarks. Check out reviews and comparison benchmarks for the processors you're considering. This will give you a clearer picture of how they perform in real-world scenarios. Check for pre-applied thermal compound. When processors come with coolers, the heatsink might already have thermal compound applied. This can save you some hassle during installation. By keeping these factors in mind, you'll be able to choose a processor that not only fits your motherboard but also enhances your system's overall performance. Let's walk through the general procedure for installing an Intel processor. Here's how to do it step by step. Use ESD protection. Start by using an electrostatic discharge strap or wearing anti-static gloves to prevent static electricity from damaging your components. Power down and unplug. If you're replacing a processor, power down the system, unplug the power cord, press the power button to drain any remaining power, and open up the case. Remove the socket protective cover. Take off the protective cover from the CPU socket. This cover keeps the socket clean and protected. Lift the socket lever. Push down on the socket lever and gently push it away from the socket to lift it. This will unlock the socket. Raise the socket load plate. As you lift the lever, the socket load plate will rise, preparing the socket for the new processor. Remove processor protective cover. If your processor has a protective cover, carefully remove it without touching the pins or contacts. Align the processor. Place the processor into the socket, aligning it so the notches on its edge line up with the posts embedded in the socket. Ensure proper alignment. Double check that the processor is aligned correctly in the socket. It should fit snugly and evenly. Lock the processor in place. Push down on the lever and gently return it to its locked position. This action secures the processor in place. By following these steps, you'll have your Intel processor installed correctly and ready for use. Now that we've got the processor installed, let's move on to the cooler assembly. Here's a step-by-step guide to getting your cooler set up. Understand cooler posts. First, familiarize yourself with how the cooler posts work. These are the components that secure the cooler to the motherboard and help with heat dissipation. Apply thermal compound. If the cooler doesn't come with pre-applied thermal compound, you'll need to apply it yourself. This compound helps to improve thermal conductivity between the processor and the cooler. Heavy coolers and backplates. For heavier coolers, you might need to install a backplate underneath the motherboard. This provides additional support and stability for the cooler. Install the cooler. Once the backplate is in place, position the cooler on top of the processor. Make sure it's aligned properly and then secure it according to the cooler's instructions. Secure lighter coolers. For lighter coolers with locking pins, ensure that the pins are turned counterclockwise as far as they will go before locking them into place. This ensures a tight fit. Connect the cooler fan. Don't forget to connect the power cord from the cooler fan to the motherboard. This allows the fan to operate and keep your processor cool. Check BIOS, UEFI. Finally, boot up your system and check the BIOS or UEFI setup to make sure the system recognizes the processor and cooler. With these steps, you'll have your cooler assembly installed correctly, helping to keep your processor running smoothly. Let's go over how to install an AMD Ryzen or Athlon processor. Follow these steps to get it done right. Open the socket lever. Start by opening the socket lever and removing the protective cover from the socket. This gets the socket ready for the new processor. Position the processor. Align the processor so that the 4 empty pin positions on the bottom match up with the 4 filled holes in the socket. Carefully place the processor into the socket. Check the fit. Make sure the processor pins are slightly seated into the holes. This ensures that the processor is correctly aligned. Secure the processor. Press the lever down and gently lock it into position. This secures the processor in place. Apply thermal compound. If the thermal compound isn't pre-applied on the cooler, apply it to the top of the processor. This helps with heat transfer. Install the cooler. Attach the cooler by clipping the clipping mechanism into place on one side. Make sure it's securely fastened. Connect the fan power cord. Finally, connect the cooler's fan power cord to the 4-pin CPU fan header on the motherboard. This powers the fan and keeps your processor cool. With these steps, your AMD processor will be installed and ready to go. Knowledge check. What is the first step when installing a new processor onto a motherboard? A. Apply thermal compound to the processor. B. Open the socket lever and remove the protective cover. C. Connect the power cord from the cooler fan to the motherboard. D. Verify the processor pins are properly aligned with the socket holes. Answer. Open the socket lever and remove the protective cover. When installing a processor, the first critical step is to prepare the socket by opening the lever and removing any protective cover. This allows you to safely place the processor into the socket without damaging the pins. Applying thermal compound and connecting the cooler are important, but these steps come after the processor is securely positioned. Verifying pin alignment is crucial, but it also follows the initial step of preparing the socket. Let's dive into random access memory, or RAM, and the different types of memory modules you'll encounter. What is RAM? RAM temporarily holds data and instructions that the CPU needs to perform tasks. Think of it as the short-term memory for your computer. It helps your CPU quickly access the information it needs while you're working on something. Dynamic RAM. Most of the RAM you'll deal with is dynamic RAM. DRAM needs to be refreshed thousands of times per second because it loses its data rapidly. This constant refreshing is handled by the memory controller. Memory module types. There are two main categories of memory modules. DIMM, Dual Inline Memory Module. This is the type of memory module used in most current desktop motherboards. DIMMs are larger and provide the capacity needed for desktops. SO-DIMM, Small Outline DIMM. These are used in laptops. SO-DIMMs are smaller and more compact, designed to fit into the tighter spaces within laptops. Understanding these basics will help you in selecting and installing the right type of RAM for your system. Let's talk about DIMMs and the different types of DDR memory, which are key to understanding how to upgrade or replace RAM. DIMM basics. The D in DIMM stands for dual, referring to the independent pins on both sides of the edge connector. This design allows for more data transfer and better performance compared to older memory modules. DDR memory evolution. DDR, double data rate. When DDR was first introduced, it ran twice as fast as earlier DIMMs, boosting overall performance. DDR3. This version uses 240 pins and is not compatible with other DIMM types. You'll notice it has different notches to prevent incorrect installation. DDR4. DDR4 memory is faster and uses less power than DDR3. It comes with 288 pins and has a single notch in the edge connector, making it easy to distinguish from older types. DDR5. DDR5 takes things up a notch with even faster speeds and lower power consumption compared to DDR4. It supports up to 64 GB of DRAM and also uses 288 pins, but the notch is positioned closer to the center, so it's not compatible with DDR4. Understanding these differences is crucial when selecting or upgrading memory for your system. Make sure to check the type of memory supported by your motherboard to ensure compatibility. Now let's explore what affects the capacity, features, and performance of DIMMs. Understanding these factors will help you make informed choices when upgrading or troubleshooting memory. Number of channels. DIMMs can be used in different channel configurations: single, dual, triple, or even quad channels. More channels can improve performance by allowing the memory controller to access multiple DIMMs simultaneously, boosting overall system speed. Capacity per DIMM. The amount of RAM on a single DIMM affects your system's total memory capacity. Larger DIMMs mean you can install fewer modules to achieve the same total capacity, which can be useful for keeping your system organized and managing heat. Speed. The speed of a DIMM, measured in MHz, indicates how quickly it can read and write data. Faster memory speeds can enhance performance, especially in memory-intensive applications. However, your motherboard and CPU must support these speeds to take full advantage. Error checking abilities. Some DIMMs have error checking features, such as ECC, error correcting code, which helps detect and correct data corruption. This is particularly important in systems where data integrity is crucial, like servers or workstations. Buffering. Buffered or registered DIMMs include an additional register that buffers the memory controller's commands. This can help stabilize memory in systems with large amounts of RAM, though it is typically found in server-grade memory rather than consumer systems. Memory channels directly affect how fast data moves between your system's memory and processor. Single channel. The memory controller accesses one DIMM at a time, which can limit performance. Dual channel. Doubles the speed by accessing two DIMMs at once, like widening a road for faster traffic. Triple channel. Some motherboards can access three DIMMs simultaneously, improving speed further. Quad channel. The best option. 4 DIMMs accessed at once for maximum performance. DDR3, DDR4, and DDR5 support dual channels, and DDR3 can use triple channels. Quad channels are available on supported DDR3, DDR4, and DDR5 motherboards. Using multiple channels can significantly boost your system's speed. For dual, triple, or quad channels to work, both the motherboard and DIMMs must support the technology. Motherboards often color-code DIMM slots to guide you on how to set up these channels. To enable dual channeling, ensure the two DIMMs are matched in size, speed, and features. Using the same manufacturer is recommended. For triple channeling, install 3 matching DDR3 DIMMs in the appropriate slots. Following these guidelines ensures you're getting the most out of your system's memory configuration. If your motherboard supports quad channeling, expect it to have 8 memory slots. Each of the 4 channels will have 2 DIMM slots. The processor can access all 4 channels simultaneously, boosting performance. For optimal configuration, consult the motherboard user manual to determine the best slots to populate. DIMM speeds are measured in megahertz or PC rating. The PC rating measures total data bandwidth between the module and CPU. To calculate the PC rating for a DDR4 DIMM, multiply the speed by 8, since it has an 8-byte data path. For example, a DDR4 DIMM running at 3000 MHz has a bandwidth of 24,000 MB per second, labeled as PC 424,000. DDR4 PC ratings are identified as PC4. Error correcting code, or simply ECC technology, ensures reliability in memory modules. ECC DIMMs have an extra chip for error correction. It compares bits written to memory with those later read, detecting and correcting single-bit errors. If 2 bits are in error, ECC can detect but not correct them. ECC uses a 72-bit data path, with 8 bits dedicated to error checking. Buffers and registers help hold and amplify data signals before writing to the module, boosting memory performance in servers. Some DIMMs use buffers or registers, while others use neither. Registered memory is often labeled RDIMM. Column access strobe, or CAS latency, measures access timing, the number of clock cycles needed to read, write data on a module. CAS latency is often listed as a series of numbers in memory ads. Modern laptops typically use DDR4, DDR3L, or DDR3 SO-DIMM memory. The specific memory type must match what your laptop supports. The number of pins and notch positions on SO-DIMM modules ensure you can't insert the wrong memory into the slot. Virtual RAM, or virtual memory, allows Windows to use hard drive space to supplement system RAM. It's stored in pagefile.size, a hidden file on drive C. If there's not enough free space on C, the page file may shrink, leading to low memory warnings. Upgrading memory by adding more RAM can help solve issues like slow performance, applications not loading, system instability, Windows showing insufficient memory errors. When upgrading memory, check the limits of the motherboard, processor, and operating system. Windows needs at least 1 GB for 32-bit and 2 GB for 64-bit installations. Windows 10 Pro, 64-bit, can support up to 2 TB of memory. 32-bit Windows 10, 9, and 7 is limited to 4 GB of memory. Start by opening the case and checking the memory slots. Count the slots and see how many are filled. Review the module imprint. Examine the motherboard for the manufacturer and model. Read the motherboard documentation to confirm support for dual, triple, or quad channels. If unsure, take the motherboard and existing memory modules to a computer parts store for confirmation. In reviewing the motherboard documentation, determine its maximum memory capacity. Single DIMMs can be installed but won't be as effective as matched pairs. For DDR4 dual-channel DIMMs, install matching modules in each channel to maximize performance. For DDR3 triple-channel boards, use 3 matching DIMMs in the designated blue slots. Adding a 4th DIMM will switch to single channeling. When selecting memory modules, consider the following. Avoid mixing unbuffered with buffered or registered memory. Match manufacturers if possible. Mixing speeds will cause all modules to run at the slowest speed. Research online using tools to match modules to your motherboard. When picking out memory modules, keep these tips in mind. Don't mix unbuffered memory with buffered or registered memory, it just won't work. Try to match manufacturers if you can, it helps with compatibility. If you're mixing memory speeds, all your modules will run at the slowest speed, so aim for consistency. Do your homework online. Use those handy tools to make sure your new memory matches up with your motherboard. Here's how to install your DIMM modules. Pull out the arms on the sides of the slot to open it up. Use the notches on the DIMM's edge connector as a guide. Insert the DIMM straight down into the slot. Once the DIMM is fully in, the clips will snap back into place. When you power up your computer, it will count the new memory. Head into BIOS, UEFI to check if the memory is recognized. Before you dive into upgrading your laptop's memory, make sure you're not voiding the warranty. It's always good to check first. Here's a quick guide to help you through. Find the right part, search for authorized and compatible memory. Decide how much memory you want to upgrade. Purchase the memory. Install it just like you would on a desktop. And remember, match the type of memory to what your laptop supports to ensure everything works smoothly. Knowledge check. Which of the following statements about DDR4 and DDR5 memory is correct? A. DDR4 memory uses 288 pins and has a single notch in the edge connector, while DDR5 memory uses fewer pins and has multiple notches. B. DDR5 memory is faster and uses less power compared to DDR4 memory, and both DDR4 and DDR5 use 288 pins but are not compatible due to different notch positions. C. DDR4 memory is faster than DDR5 memory and supports up to 64 gigabits DRAM, whereas DDR5 memory supports a maximum of 32 gigabits DRAM. D. DDR4 memory uses 240 pins and has a different notch position compared to DDR5, which uses 288 pins with the notch closer to the center. Answer. DDR5 memory is faster and uses less power compared to DDR4 memory, and both DDR4 and DDR5 use 288 pins but are not compatible due to different notch positions. DDR4 memory uses 288 pins and has a single notch in the edge connector. DDR5 memory is indeed faster and more power efficient compared to DDR4. Both DDR4 and DDR5 memory modules use 288 pins, but they are not compatible with each other due to differences in the notch position, with DDR5 having the notch closer to the center. Alright, folks, it's time for a quick self-assessment to see how well you've grasped the content we've covered. Grab a pen and rate your understanding of each major concept on a scale of 1 to 5, where 1 equals not confident at all and 5 equals highly confident. Understanding processors. How confident are you in analyzing the characteristics and features of processors used in personal computers? Processor installation and upgrade. How sure are you of your ability to select, install, and upgrade a processor? Physical memory types. How well do you differentiate among various types of physical memory and understand their operational mechanisms? Memory upgrade skills. How confident are you in performing a memory upgrade? If you rated yourself less than a 4 on any of these, don't sweat it. Go back and review the sections where you feel less confident or seek out additional resources to boost your understanding. Keep pushing forward. You've got this. Thanks for tuning in to today's presentation. We've covered a lot of ground, from understanding different types of processors and their features to diving into the details of physical memory, including installation and upgrades. Remember, whether you're upgrading your own system or just learning for future projects, these concepts are essential for ensuring your PC runs smoothly and efficiently. If you found this video helpful, please give us a thumbs up. Your support really helps us keep creating content. Don't forget to hit that subscribe button and ring the bell so you don't miss any of our future videos. Share this with your friends, and leave us a comment below with any questions or topics you'd like us to cover next. Thanks again for watching, and we'll see you in the next video.